left is an approach typically seen in the United States. The traditional path consists of 2 algebra courses and a geometry course, with some data, probability, and statistics included in each course. On the right is an approach typically seen internationally and used by a number of countries that outperform the U.S. in standardized testing. The integrated pathway has been adopted in several U.S. states, including New York and Montana, and New Hampshire districts, including Bow, Sauhegan, and Lisbon. The integrated pathway consists of a sequence of 3 courses, each of which includes numbers and operations, algebra, geometry, probability, and statistics. Ultimately, both of these pathways will prepare students for training after high school, coursework after high school, and coursework in higher level mathematics like pre-calculus, calculus, and statistics. The benefit of the integrated math pathway is it attempts to help students see the connections and interrelationships between the 3 domains of algebra, geometry, and data analysis. In their traditional sequence, these connections are not often made until students reach pre-calculus. Students often ask this question.
Why are we learning this?
Why are we learning this?
Learning how to rationalize a denominator is much like learning how to find a common denominator in a fraction. Traditionally, we learn it at the end of an Algebra 1 course and do not need it to use it in context until the end of a geometry course. When we start to use it in geometry, we need to go back and review how to use the skill because we haven't seen it recently. In integrated math, students still learn the skill of rationalizing the denominator, but they use it again in the next unit. Here's an example that utilizes the skill. Rangers are in a lookout towers, A and B, looking at a fire. When the ranger calls to report the fire, they must report the distance from the lookout tower to the fire. You may see right here that rationalizing a denominator is simply one step in the process. Students will see that a problem that started off as a geometry problem, given angles and asked to find a distance, became a problem utilizing algebra skills. The integrated math curriculum will be sequenced so students will have the necessary algebra geometry skills to approach real-life, multifaceted problems. I would like to suggest the following analogy by relating math curriculum to sports. In sports, we've never seen a coach say this season we're going to focus on defense and next year we will focus on offense. Most coaches would agree a blend and working on the transition between offense and defense is key in success. The same is true for mathematics. Algebra and geometry are both very important, but the connection between the 2 concepts is crucial. Teaching as separate entities will not be as meaningful to students as if they are taught in a natural sequence.